With this one, it says A, state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval, and then B, if it does, find the value of C on which AB satisfies the mean value theorem. So first of all, we need to know whether or not this works, the mean value theorem works on this interval. So what I'm going to do is I'm going to graph it really quick. So this function is going to be x minus 1, so it's just going to be a regular logarithm. Now a regular logarithm goes through the point 0, 1 and kind of looks like this. But this is going to be shifted right 1, so it's going to be here, and it's going to go from here to here. And so we want it from 2 to 4, so 2 to 4. The only conditions that have to happen is, number one, it has to be continuous and it has to be differentiable. If you look, it is continuous and it is differentiable on every part. So pretty much what we're doing is we're going to be trying to find a tangent. We're trying to find this x value in which this tangent is going to be the same. So if I just take this line and I put it on the function, it should be somewhere around there. So that's what we're trying to do. We're trying to find a tangent line that is parallel to the secant line on this interval. So what we need to do is the definition's right here. In other words, the derivative at some point is going to equal the secant of these 2 points. So first of all, I'm going to find this right here. So I'm going to be finding this. So that is going to be, well, I need f of x2. Well, f of x2 is going to be 4 plugged into here. So it's going to be the natural log of 4 minus 1, which is the natural log of 3. And then it's going to be minus 2 plugged into here is going to be 2 minus 1, the natural log of 1. All over x2, which is 4 minus 2. Well, the natural log of 1 is who knows. But if I put it in exponential form, it's going to be e to the who knows equals 1. And what question mark is going to be in order to get 1 is going to be 0. So the natural log of 1 is 0. And the natural log of 3 I don't know, so I'm just going to leave that there. So the natural log of 3 divided by 4 minus 2, which is 2. Now, the next thing I need to do is I need to find the derivative at c. Well, this is going to be f of x. So the derivative of f of x is going to be 1 over x minus 1. So the derivative at c is going to be just 1 over c minus 1. So now all I got to do is take this green and set it equal to the red. So I take the green and set it equal to the red. Now all we got to do is solve from this point. So I can actually cross multiply at this point, and I can get the natural log of 3 multiplied by c minus 1 equals 2. I want to get c by itself, so I'm going to distribute this. Natural log of 3, c natural log of 3 minus the natural log of 3 equals 2. Add a natural log of 3 over. 2 plus the natural log of 3, and then divide by natural log of 3 on both sides. So essentially, c is going to be 2 divided by the natural log of 3 plus the natural log of 3 divided by natural log of 3, which is just 1. So that is where it's going to happen. Now, if you want a decimal approximation, we can just stick this in our calculator. And that is going to be 2 divided by the natural log of 3. I'm going to find that, and then I'm going to add 1 to that. So if I want a decimal approximation, it's going to be about 2.82. To get a more visual idea of what's going on, let's look at the graph. Graph of it's going to look like this. And we want the interval from 2 to 4. And so we want to take a line that connects those two. And what I'm going to do is I'm going to copy and paste this line. And it says that it should happen about 2.82, which is going to be about right here. So if I place this line right there, it should be the derivative at that point. And it looks like it's doing a pretty good job.